Okay, so let's wait for 2 more minutes and then we will start the session. Okay, so let's just start the session. Good afternoon, everyone. As in the previous chapter, we learned about how to integrate R with Hadoop with the help of Repay. Let's just open the slide. With the help of Repay and R Hadoop. Also, we saw some sample examples. In this chapter, we are going to discuss about the following topics: introduction of this R with streaming with Hadoop, and then understanding the basic concept of Hadoop. Then after we will understand how to run Hadoop streaming with R. Then what is the MapReduce application in this context, and exploring the stream R packages which we are going to use or which are the functions that are available in R package. So let us start with the concept, understanding the basics of Hadoop streaming. So Hadoop Streaming is a type of utility for running the MapReduce application with executable scripts such as mapper and reducer. This is similar to the pipe operation in Linux, if you recall the application. So in this, the text input file is printed on the stream, that is with the use of stdin, standard input, which is provided as an input to the mapper function, and then the output, that is stdout of a mapper, is provided as input to the reducer. Okay, then after that, reducer write the output to the hdfs directory. Let us just understand the flow. First of all, we will streaming the input to the mapper. Then after that, the output from the mapper is given through std out to the reducer. And finally, the result will be stored in the HDFS. Okay. So the main advantage of Hadoop streaming utility is that it allows Java as well as non-Java programmers so MapReduce job to be executed over the Hadoop. Also, it can take care of progress of running MapReduce jobs. The Hadoop streaming supports not only just Java but also the Perl, Python, PHP, R as well as C++ programming languages. To produce an application written in other programming languages, the developer just need to translate the application logic into the mapper and reducer sections with the key and the value as an output element. Okay. So we learned in the second chapter that writing Hadoop MapReduce program and that we used to create the MapReduce job, we need a mapper, reducer, as well as driver as the three important concepts. Once again, I'm repeating Hadoop MapReduce job. To execute the MapReduce job, we need a mapper, reducer, as well as a driver as the three important concepts. Okay, so driver is the optional part. Here we can create a driver for running the MapReduce job, which is optional when we are implementing the MapReduce with R and Hadoop. So in this chapter, we are intention of integrating the R with Hadoop. So we can see the example of R with Hadoop streaming. We will see how we can stream with Hadoop and R script written in the MapReduce jobs. So we have a diagram, the method which will seamlessly integrate the R and Hadoop with without the Java knowledge, so that we can write in other programming languages. So here we are having the workflow. We are having different type of languages, as we can see: C++, Perl, Python, R, and Ruby. And these are provided. These are the languages that we are writing as a school, and these are provided to the MapReduce functions. Okay, so mapper and reducer. So we can have the R scripts which are written in mapper and reducer. From the above diagram, we can see that we can identify various components of streaming of MapReduce job. Now let us just assume that we have mapper and reducer codes such as code underscore mapper.r, that is first file for mapping, and for the reducer we are having code underscore reducer.r. So these are the program written in the following programming languages. So we can see how we can integrate such type of environment using the mapper and reducer. Then we are providing the input and output directory to the Hadoop stream, and later the jobs will be provided. Map and reduce job will be executed on the Hadoop cluster. So this is the overall diagram of Hadoop architecture. We can say that. Okay, now we are going to understand how to run basically this type of program. Understanding MapReduce application, how to code in the MapReduce application, how to run this MapReduce application, because it's a quite difficult process, complex process. Understanding how to explore the output from the MapReduce application. Once again, I'm repeating, understanding the overall MapReduce application. After that, first part will be how to code in MapReduce application. Second part, how to run the code which we wrote in the MapReduce application. After that, how we are going to explore the output. So this is the complex process. We need to pay attention more here. Then, what are the means? What is the integrated environment? What we need to understand? Here we can run them as an integrated environment of R and Hadoop. This we can run with the help of R streaming command with the generic and streaming options. So this is the option that we can use bin slash Hadoop command. Then generic options that we are providing with streaming options. So let us understand what is this scenario. For running the Hadoop streaming with R, we need a certain type of prerequisite set here. First, we need to install Hadoop and configure it on our system. Basically, we will prefer the Ubuntu operating system from the Linux distribution. Then we can install R on our Hadoop cluster, and we have to ensure that the R scripts, that is command line execution, are available inside our system. So this is the graphical representation that we can say with the help of the previous architecture. We are providing the input data. Then this is the mapper. Let's say we have the coder underscore mapper function inside the mapper. Then we will shuffle the output using the shuffle and sort the process using the Hadoop, and we will give it to the Hadoop reducer as an input. Then Hadoop reducer will convert into the HDFS as a result. Let's say, for example, this is our input text file. So we can see that this is in the first page, this is our input data. Okay. So the input data, inside the input data, we are having the text such as Hadoop streaming example using R. This is our first line. Second line is Hadoop is powerful. Third line is Hadoop is scalable. And the fourth line is streaming allows R integration. So these are the four lines. And yesterday also we saw about the word count program. So if we want to calculate how many times the Hadoop is going to be there, or a Hadoop is there in the text file. So this is number one. Then we will have index number one. Hadoop has two, Hadoop has three. So the total number of count, the sum of the count will be three here. So we are writing the mapper function here as we previously discussed. So this is the type of this is the command that we can use. Mapper is a scripts that read a line by line. This is the important part about the mapper. And we are having a split. We will split the words, and we can see that there are output of the key value pair provided by the mapper function to the reducer function. Okay, so this is a script for the input data that we are having the stdin as a processed it by line by line. Okay, so wait a minute, someone wants to join. Okay, so this is the R script that we read the input from the standard input and process it line by line, splits each line into words. We are splitting each line into words, and input of each word will be followed by the number one. So how many type Hadoop is there? We will count one, two, three. So it is typically used in the MapReduce framework like a Hadoop streaming for word count. Let us break it down one by one. Okay. So what is this line? User slash bin environment R script. So this is the line that tells the system that this script should be executed using R script, which is interpreted by the R script. Okay, so total lines, this line will be ensuring that the script uses the first R script binary found in the user's path and making it more portable across the different type of system. That's why we are having this environmental setup. Then we will capture such type of a command, that is command arguments trail only true. This means that it will extract the command line argument passed to the script and ignoring the standard R startup arguments. Okay, so this can be useful when scripts needed to handle as an input parameter or configuration. Okay, so that's why we are using this command. Then we will have the connection file. Okay, so it will open the standard input file and reading open. It will open in the reading mode, and this will be useful when the script is used in the pipeline where the input is provided dynamically, such as Hadoop streaming jobs, where we provide the input. Then we have this while function, as we do not know how many number of lines will be there. So we will using the while loop. So we can say that read lines con number one and var is equal to false means that it will read line one by one from std input. Okay, so then we have the line while loop continues as long as there are number of lines to read, and length line is greater than zero. It states that the ensures that the loop stops where there are no number of lines. So that is why we are having this condition. So we are splitting the data here. So words unless the string split line s plus, so it will indicate that the string split splits the line into the number of white spaces. There are no number of white spaces, that is blank spaces. And the unlist function makes sure that it will convert our output from a list vector of words. So it will convert to the vector words, and the loop will be executed for while from word to words. So a loop will execute each iteration in the vector words, and the cat word t slash t, the line will indicate that the print word followed by one and separated by the tabs here and followed by the new line. Okay, so this is what the code says. And then we have the connection close command that will release the system resources, and this script will process the each word and emits word comma one. So how many times the word is going to repeat? For example, Hadoop one, then we have Hadoop thrice. So total number of sums will be there. And then we have the reducer. In the reducer, we can say that this is a reducer command which counts the total number of process, and the key value made by the previous the MapReduce will be provided here as an input for the each unique word. And also we can say that this command user slash bin, it is also called as in the C++, we can call it as header file, and in R we can say that is a shebang line. So it specifies that the script should be running in the R script only, and with ensuring the portability of the system. So if you are having different type of system, we can run the same script. So to capture the command line argument, we are having this command line argument trail only and word counts. So this line will capture any number of commands that we are having and not use the further in the script. And this word counts is list indicates that it is associated with array hash map, and to store the count of each unique word we are having this line, and the keywords and the values will be cumulative counts here. So the standard input output given opening here by the reading mode. So this one is the line. Then we are using the while loop again here. So we are reading the one line at a time using the standard input and continuing the same until no line is there. Okay. So parts list, this will entire section will be there. So these three lines indicates that the string is split it into the white spaces and no white spaces, then we are having again the unlist function. The purpose of unlist function is to convert the result into the character of vectors, and part 1 and part 2 will be there. So part 2 will store the word, and part 2 will be storing here the count, total number of counts. Okay, so there is logic of if else. It indicates that if the word is already in the counts, then update the count. Okay, so Hadoop is there. If Hadoop is present in the first line and also it is present in the second line, we will update the count. And if word is not there, then we will view it as a count. For example, there is a word, then we will increase it to the one. Okay, so again we are closing the connection, and here we are aggregating the counts. For loop will be here executed here for aggregating the total number of counts, and it will iterate for each word in the word count, and it will print the total number of count, and it will be separated by slash t for the tabs, which will convert the standard output format to the map reducer here. So this is a total reducer function. Okay, to run, okay, have you cleared with the mapper and reducer function? Means what is the execution? If you have any doubt, you can ask me, or we will continue with the running the system. Okay, so if you do not have any type of doubt, then we can continue. So now that we are having two different files, mapper.r and reducer.r, that we have seen just recently. So this is reducer.r and this is mapper.r. Also, we have provided the input here. This is our input file. Okay, input text. Then we are having the mapper.r program as well as reducer.r program. Okay, so chmod, ch means we can say that in Linux this command is very much used. Ch means changing the mode. Chmod means changing the mode to the execute mode. We will execute the file. Which file? Mapper.r. So this one executable file will be executed, and chmod again changing the mode to the executable file reducer.r. So I have mentioned here the command chmod plus x file name add to the executable permission to the file, so that it can be recognized by our Linux system. Okay, so this is the line by line. This is the Hadoop streaming command option. We are having different type of commands which are given to produce the output. So line number one is here Java jar file is here. Hadoop home and contribution.jar. As we know that jar are executable files, and we are adding the class path here. Then we are having the second number line as input app Hadoop input. So this line is used for specifying the input directory to the HDFS. Then we are having the third line as output app Hadoop output. So this third line will be here for specifying the output directory to HDFS. Fourth line will be there file user local Hadoop code mapper.r. So I have changed here. We just renamed this as a mapper. This is not a code mapper.r. So this is there for making the file available to the local machine, and then to running and show the output. Okay, so fifth line will be indicated that we are using the define available file to the mapper. Okay, so sixth line will make sure that this is used for making file available to the local machine, and seventh line will here as we can see defining the available R file to the reducer. So these are the type of command that we need to give to the Hadoop command outlet. Okay, so to run the whole program or run the whole system for the result, we can have this type of command Hadoop DFS, that is cat output directory and part. This one is the command that is used to check the output, and we can see that from the previous line we have Hadoop twice, right? From the input, we can see that Hadoop is mentioned twice. Streaming is given once, allow one, example one, integration one, and is keyword is there for twice, powerful one, scalable one, and using one. So this is the total output of our MapReducer function. Okay, so what are the key aways that we can take away? So Hadoop streaming allows R script to process the large data set into the distributed manner. That is the key functionality. Then mapper and reducer in R work with the standard input and output using stdin and stdout. So execution requires Hadoop streaming jar and R scripts, and this method enables the statistic computation of R with the processing of Hadoop. So that is the key away here. And again, there are the six important streaming components. These are used for the execution. For example, the jar file, it is used to run the coded classes that are designated. Okay, so we can know that that is a jar file. Then the input is given as a data set or text file to the mapper function. Then we have the output. Then output will be there. We are having the file for option that is used for copying the MapReduce sources such as mapper, reducer, and combiner to make it as local. Then we have the mapper to use to identify the executable file that is recently we saw that mapper.r file. So this is recognized using the mapper and the reducer. This files will be these two will be there in the Hadoop cluster. Okay. So what are the packages? Next concept is what are the packages that we can see inside the Hadoop streaming packages. So Hadoop streaming is basically a package. It's not a collection of packages. Sorry. So Hadoop streaming is a package. It is totally a package that was developed by David S. Rosenberg. Okay, and we can say that this is a simple framework for MapReduce scripts. We can have different number of scripts running here with the three most important features that we can see. It will the data will be readed here chunk wise. That is a decomposition of data will be there, and it will be readed chunk wise. For example, if you do not know what is meant by chunk, if there is whole data and we are segmenting the data, it's dividing the data into different type of chunks. Okay, so that is called as chunking, and the data will be readed by chunk here. Then the support various type of data format for which we are having three different functions. Okay, so that is why we are having three different functions as HS table reader or key value reader. So there are if there are different type of format of data, such as data is present in the table format, or data is stored in the key value format, or data is stored in the line format. So it can be supported by this streaming package. Okay, so, and robust utility, you can say about it as robust utility for streaming command. The package also allows user to specify the command line argument for Hadoop streaming. So now let us understand about each of these functions which are mentioned inside the Hadoop streaming. We are having the three most important function here, and these are the exact functions that you are supposedly asked for the university exam. So these are the three functions that are majorly asked. You can see in the university question bank as well. So we are having the HS table read, then we have HS key value reader, then we are have HS line reader. So what are these type of different functionality? These functionality are from the various type of data format that I explained earlier. So these are the three different type of format that we are having as input inside the Hadoop streaming. Now let us understand one by one what is the HS table reader function. The HS table reader function is designed for reading the data from the table format, and this function assumes that there is an input connection established with the file, so that sorry, please wait for a second. I will be back. कंप्लीट झालं का? कंप्लीट झालंय म्हणजे एक्झिक्युशन चालू आहे का? थोडं वेळ तक अर्धा तास ऍक्च्युली मी ऑनलाईन लेक्चर घेतोय. अर्धा तास. Okay, sorry for the disturbance. Where was it? Okay. So we were discussing about the different type of functionality, and particularly we were discussing about the HS table reader function here. Am I audible? Hello? Audible? Someone confirm that? Okay. सगळे गेले तो मोबाईल फोन. So the HS table reader function, the function is there to design the reading data from the table format, and this function assumes that there is an input connection between file, so that it will run. So it will read the entire row. It assumes that the all number of rows from the same keys are stored consecutively in the input file. So that is the HS table reader. Then we can say that about the key value reader, it is for the same that the data is having the different type of format. One of the format is key value reader. The HS key value reader function decides that the reading data is available in the key value format, and this function is also used chunk size for the defining the total number of lines to be read at a time, and each line will be consist of key value strings and value pair. So that is key value. And then we have the line reader function. This line reader function will make sure that it is designed for reading the entire line as a string without performing the data passing operation that we are previously discussing. And it repeatedly reads the chunk size line from the data from the file and pass the character vector to the string as the input. So these are the three type of functions that we can see. So one by one we will discuss about their purpose, their usage, and it is the exactly same concept that you need to write in the exam as well. What is the HS table reader? First we will write the purpose and what is the HS reader function. Then we will write the usage about it. Okay, and then we can see the example of. We will refer the same example as word count for the three different functions. Okay, so that you can compare three different functions at the end. So the HS table reader function reads that tab space value from the table. It will expect that the each column is having the tab space from the standard input, and then converting the data into the data frames for the further processing. And this is useful when the processing structures the data in the tabular format. Okay, so how can we use it? The usage is given here. Data provided by arrowed by the HS table reader function. It reads the input line by line. Okay, that assumes the data in the columnar fashion by the tabs. The data is present in the columnar fashion in the table format, and it returns the output in the terms of data frame where each row presents a record. Okay, so that is HS table reader function. Now from that we can see the example, same example as a word count I have stated earlier. Same example we can refer so that we can compare each of the means, function at the end. Okay, so this is the example of HS table. Okay, what basically this line is that we can know that user slash patient slash environment. Okay, so this line is there to count the, sorry, to have the HS line that the data is run in the RA script. Okay, and then we are importing the Hadoop stream library from here. We are having the data in the format of table.data. Then we are reading the data as we have seen previously. The data HS table reader function will be there, and to convert it into data table, we have the DT function here, and the result will be stored in this type of format. And we are applying a result function cat1 column 1, and it will showing for the records. Okay, wait a second. Okay, so this one is the example of HS table. The HS table, again, this HS table reader is a function for Hadoop streaming that reads the tab space data from the key value with the standard input. And typically the standard output is piped using the reducer R streaming job. Okay, again, in this line, we can say that dt count sum v2 by v1 is equal to. So this states that the group of data will be there in the fashion v1, which contains the word, and v2 we are having the sum. Okay, so v1 is a unique word, and we will count it in the v2. Again, v1 is used for the unique words, and then apply result to one function will be there. This function will indicate that there are printed in the tab spaced format, which are standard output for the Hadoop MapReduce. Okay, so as an output, we can say that hello 2 and world 1. Okay, so this is a type of example. As an input data, from the input data we have converted into the output, and which are the use cases where we can use this function. So reading structured tabular format in MapReducer. If you are having the data as input in tabular format, there we can use the HS table. Then processing data set with multiple columns. and performing the aggregation using the data table. As we can see in the previous example, there is data table command. Okay, to aggregate the total number of, or we can use the same deep layer again function to execute the same for the aggregation. Then the second function is there, that is key value reader function. What's this function exactly says, that what is the purpose, that it will basically the format, there are three type of format, that is table format, key value reader, and line format. This one we will use for the key value reader, that is we are having the input type of data, that is std in the key value pair, where key and values are separated by tab, again same, and it in returns the named list keys for the naming spaces for the corresponding element. How we can use it? Data pointing to the hs key value reader, it will read line by line from the input. Again, it will split into the key value pair and return as a named list. Okay, so let us have example processing key value pairs. We are having input data as apple as 5, banana as 3, and apple as twice, and banana as 1. So this is our input data we are providing for the word count. Okay, so HS value reader function. This script entirely says that is a word count job. It reads the key value from the standard input and aggregate them for each key, and then print the final word count. So let us break it down one by one. What is this function? Again, I'm stating the same line again and again. This line specifies that it is executed using R script, ensuring the compatibility or portability in different type of environment or systems. For that we are having the same line. Then we are having the library Hadoop Streaming. So this is basically load the Hadoop Streaming library, which provides the helper function or basic streaming input output functionality to this program. Then we are having the key value here, key value reader. So this will ensure that the data is read from the this key value pair will be read from the standard input and output. For that we have provided the specific input here. So this will be read as a key value pair, as the name suggests, it is key value reader. This is the key section and this is the value section. It is provided as the input data. Then we are having the result line. It will show that the result apply numeric names. So this line makes sure that it converts the value into the string into the numbers. We are having the key into value. We have to convert the key into the value. The namespaces extract the total number of keys, and then t apply function will make sure that it is a unique key, and some function will aggregate the total number of count here. Okay. So naming as words, you might say, you might think that this is a difficult program, but actually it's not. With the help of practice you can have the knowledge of the same. Okay, so these are the certain type of naming words, and result are used for the total number of lines. And we are having the for loop to iterate over the each unique word that we are having. If we are having a unique word, then it will be counted, and if you are having the repeated word, that is having the some value at the end. Okay, so where we can use this hash key value. So the output of apple will be 7. How that apple will be 7, we can see from the example. The total number of apple as input we previously had was 5. And in the third index, we can see that apple with count 2 is there. So finally, we are having the word count, then this will be summed. 5 plus 2. As a result, we can see that apple is indicated with the index number of 7, that is key and value pair, and banana is for 4 if that is repeated. And where we can use this type of key value paired, so it is ideally for the input for key value processing, and suitable for simple aggregation functions such as mean, max, such type of aggregation function there we can use, and works well with dealing with dictionary like structures. So we can have the key value pair as an input. Now that we are having the third function as HS line reader function, we are having the input as raw lines of text, as we can see. Okay, what it indicates that the function read raw lines of text from the standard without splitting them into the fields, and this is useful when processing the unstructured data such as logs. I have previously stated the example. If you are processing the logs, then logs having different type of login functionality or the survey information or error logs, what type of data it is having in the logs, or we have the JSON type of format, or we have three text files, so that where we can use the line reader function. What is the usage? Line reader function is indicated by the HS line reader. So it will read each line as a single character from the string, as we are having the unstructured data, okay, in the text format. It does not split the data into columns or key value pairs. So that is in the previous example or previous function we saw that, and it returns a vector of strings. Again, we are having the input as an raw text file and output as a vector of strings. Okay, again, we will see with the example. Suppose we are having this input log file. There is a server, and in the server we are having the raw file as error disk failure at sector 15, and the second will be info system is rebooted successfully if that system is restarted. Then we are having the third line as warning, and we are having fourth line as network. Sorry, error. So while we are talking about the raw files, we can count the total number of words that are having the error. So how many type of error are there in the system? So we can count that. Again, the same line, again I'm repeating, it ensures that the script is using the R script on the portable, any type of distributed system, we can run the script. Then we are importing the library function, Hadoop Streaming. Again, it is for the same. It loads the Hadoop Streaming library, which provide the functionality to handle the Hadoop Streaming using input and output functionality. Okay, then we are having the HS line reader function. The write return function will read all the lines from the standard input using the stdin. Okay, and store them into the character of vector. That's why we are having this line reader function. Okay, then we are having the error lines. So we will group the error lines. So it will search for the starting with the error, the line which will be starting for the error, and then we can say that the value, if the error is repeated twice or thrice, we can increase the number of value here. And error line stores all the data having the error number here. So that is why we are using the keyword group here for grouping the errors. Okay, and finally we are having the for loop in which error lines will be there, and it will be continued. The loop will be continuous for each error line, and it will print the standard input, which are Hadoop clusters as a mapper output. So this is a standard program. As an output, we can say that there are two errors. Okay, so input as an input we are having two errors. Okay, so we can see that we are having total number of two number of errors: disk failure at sector 15 and second error as a network timeout. Okay, so where are the what are the use cases where we can use this? Processing unstructured text such as logs, JSON, and CSV, means there is unstructured text format. Okay, extracting specific pattern for the regular expression, and filtering and transforming the raw textual information. There we can use the same functionality. Okay, so we can see the comparison of these three functions, and it is highly important in the university exam as well. What are the functionalities or what are the function available inside the package Hadoop streaming? So these are the three functionalities where we can see that from the input format we are having three different functions. First one, we have the tab spaced value, that is means we are having the tabular data here as an input format. In the second, we can see there are key value pairs, and in the third we can see that there are raw or unstructured text data here. So these are the three different input format, and the output format from the table reader, HS table reader, is the data frame, and we can see that the key value reader having the output format as named list, and HS line reader having the character vector. So these are the output formats, and we can see the best use cases for which these are using. So processing unstructured tabular data, for that we can use the HS table. For processing dictionary-like key value data, we can use the key value reader. And for handling unstructured data, we are having the line reader function, HS line reader function. So this is the total comparison or total conceptual understanding of these functions available inside the R package. I hope that you can understand the how we can run the Hadoop streaming programs, how we are having different type of functionality inside the R packages. Okay, so that's all about this session, and we will continue the next in the next session from the fourth unit. And thank you for hearing. You can send your attendance in the chat box, and if you have any doubt, you can contact me as well. Okay, okay, Dhanraj Kumbar. Again, you can ask me about your doubt. Hello. Okay. You're directly submitting your attendance. That is also fine. Again, I am referring the same book for this unit, and for next unit as well, we will refer the same book, and it is available on the Moodle itself. Okay, so you can access it. Okay, thanks for listening. If you mention the attendance in the chat box, then you can leave the session.